Hello, and welcome back to the Carbon Capture Magazine podcast. I'm your host, Danielle Piekarski, and today I am joined by Chia, Global Head of Carbon Capture and Hydrogen Solutions at Honeywell. May, thank you so much for joining me on the podcast today.
Oh, it's great to be here, Danielle. Thanks for having us.
Of course. Well, to get started, would you mind telling our listeners a bit about yourself and what you do in your role at Honeywell?
Yeah, so I've been in the energy industry for more than 20 years. And the last 4 years, I've been focused on carbon capture and hydrogen, primarily in pre-combustion and post-combustion applications. Being in the energy industry, we have been using these technologies for many years in gas treating. And what we've done in the last few years is taken technologies that we have deep industry knowledge of and reapplied them into places where they can be used to capture CO2 from both post-combustion and pre-combustion applications. So that is the primary focus for our business today.
Okay. And I know Honeywell has been involved in carbon capture for decades, but how has your customer interest evolved over time, and what's driving the current momentum behind CCUS adoption?
We're actively expanding our carbon capture business through multiple different approaches. The question you asked was, how has customer interest evolved over time? I would say that customers have significantly changed the way they approach developing projects and operating their plants. Customers today are very conscious about making plans that include reducing their carbon footprint or their emissions across their existing infrastructure, and also when they're developing new projects. So, for example, if you think about a power plant, today the conversation is not, I need a power plant. I need this amount of power. I need a power plant that's ready to be capturing CO2. I need to think about, should I locate this power plant in a place where I can sequester that CO2? And what's the most cost-effective way for me to bring new power online that has a lower carbon footprint? And the way that Honeywell is approaching this change in the customer profile is through five main pillars. First of all, innovative solutions. So we've launched in the last couple of years our advanced solvent carbon capture technology, which enhances CCS proficiency and allows for smaller, cost-effective equipment. For instance, like the 650 megawatt coal-fired power plant, using Honeywell's ASCC technology could capture 3.4 million tons of CO2 per year, which is equivalent to like 735,000 cars off the road. The other thing we're doing is, as we look through this whole ecosystem of projects, we have focused on partnerships and collaborations to enable end-to-end solutions that accelerate project growth, let's call it that. So our strategic partnerships within the oil, gas, and chemical sectors have allowed us to actually take existing solutions from those areas and translate them into the hard to abate sectors like power, steel, and cement. The other area is investment in research and development. I think one of the things we all acknowledge is we need to be focused on reducing the cost, both from a capital and from an operational perspective, of carbon capture. And our R&D initiatives are focused on just that, trying to get to the best solution while making sure that it complies with industry standards and client needs. The other thing, of course, is market education and advocacy. You see us out there all the time talking about what options there are in terms of ready now technology that can be deployed on plants, such as our ASCC technology and our cryogenic and PSA options. So this puts us as a leader in the transition to a low carbon economy. Now, R&D is one thing. The other thing is with our partners, optimizations are also critical in developing the best in class solution for a given sector. Being able to innovate with the emitter and with whoever's taking out that CO2 and sequestering it or using it to produce something else is another area that has been a key focus for us. And we're establishing our technologies in both post-combustion and pre-combustion with a range of partners to be able to provide best-in-class solutions.
Great, thank you. So, if we're looking beyond traditional power plants and industrial sites, what are some of the more unexpected or emerging use cases for CCUS that Honeywell's seeing?
So we see in the hard to abate sectors, what was very interesting is the amount of CO2 that's being emitted in the steel sector and in the cement sector. So in cement production, the industry itself accounts for 5 to 8% of global CO2 emissions. And if we look at the cement area, with the higher concentrations of CO2, we have managed to deploy technology that's been used in refineries for many, many years, which is the PSA and the cryogenic technology, to be placed on the flue gas of a cement production plant and capture CO2 from that. So that is one of the interesting use cases where we look at technology that Honeywell has deep knowledge on, that we have migrated from a refining and a gas industry and now are using in the cement area. And we see a lot of projects in the cement space that are coming up. So that's one of the interesting use cases that we are focused on. The other area is in steel production. Steel emits about 2.8 gigatons of CO2. And with that again, we are looking at different options, including our solvents and our cryogenics and our PSA technology to decarbonize the steel manufacturing to meet stricter emission guidelines and improve market competitiveness in the steel space. One other area I would mention is the DAC, direct air capture technology, is something that's much more forward thinking, I guess, in the space. And we have Honeywell's DAC-SIF solution is used in multiple DAC applications to actually separate the CO2 from atmosphere.
Okay, so if we look at the Blue Spruce facility in Wyoming, that's a great example of innovation. How does Honeywell's CO2 fractionation technology contribute to both helium production and large-scale carbon storage?
So the CO2 fractionation technology is exactly what I was talking about in the cement space as well. And basically the fractionation technology separates out the CO2 into a liquid form that enables the helium to be extracted from the remaining stream. So the process helps address both helium shortages because it's doing the pre-treat prior to helium separation, and it makes helium more affordable, being able to be sourced out of the United States.
And how important is scalability in Honeywell's CCUS solutions, especially for industries that are just beginning to explore carbon capture?
Scalability is really critical, right? We see customers go through the journey of developing, and to be fair, it's not just customers, it's Honeywell ourselves. We take small ramp steps to large, big scale movements to reduce CO2. And so being able to have technology that goes from capturing 50 tons per day to technology that is able to capture 7 million tons of CO2 on an annual basis is, I think, critical in this space. And our technology is very scalable. We have projects that are as small as a pilot plant to as large as the 7 million tons that I was talking about, which is basically the Exxon Baytown Blue Hydrogen project, which is capturing 7 million tons of CO2. And how do we get this scalability built into the plant? I think one point is we have equipment that can be modularized. So with modular designs, it's easily integrated into existing infrastructure, and it allows an existing plant to continue running while you're building those pieces of equipment or those modules or those skids offsite, and reduces the amount of time that you have to interface in the plant while it's operating, right? The other thing is a technology like a solvent, like ASCC, it can scale from a very small size, the pilot plants that I was talking about, right up to the large power plants that we are currently engineering and designing. For example, our project with Crescent Midstream in the Gulf Coast, that project aims to capture and transport 3 million tons of CO2 on an annual basis. The other thing is with scalability, right? As we're looking at industries that have not had process plants in their site before. So if you think about a cement plant, you think about a steel plant, you would never think that you would have a cryogenic unit on site or a solvent system on site. And so one of the unique capabilities that Honeywell has is our combination of both deep process knowledge, but also deep industrial solutions with our Honeywell Process Solutions, where we can provide performance monitoring, which features real-time monitoring and data analytics that our engineers who are specialists can be right alongside the plant operators as we take them along this journey of learning new types of equipment and new types of processes which are in their plant now. I would say those are the main things that I would focus on in terms of scalability of CCS. One last point I'd like to make, Danielle, is we talk about these plants in carbon capture being so large and so new. The reality is they're not, because we've built plants of this size in the gas processing space, multiple units of similar sizes. So that deep knowledge that we have from pre-combustion is very translatable to post-combustion, as the pots and pans are the same.
Looking ahead, how do you see the policy landscape, like tax incentives or permitting, impacting the pace of CCUS project development?
Energy tax credits have historically spurred innovation. These credits incentivize investment, create jobs, and enable the industry to continue to innovate, to drive improved solutions and improved cost across project development. So to continue the investments, industry needs a reliable energy tax regime that will support project development across the energy sector. For example, the 45Q carbon capture tax credits are helping to underpin project development using next generation American developed technologies. In the EU, Fit for 55 is having really positive results in Europe. Policymakers can promote policies like these to facilitate the development of next generation energy markets in the near term, while advancing policies that will allow these markets to sustain themselves in the longer term. Completing these developments is critical to enabling the export of technology to friendly trading partners.
All right. Well, again, we are talking to May Chia, Global Head of Carbon Capture and Hydrogen Solutions at Honeywell. Thank you again for joining us today, May. Is there anything else that you'd like to add before we close out the podcast?
I would say that, the one thing that we have all learned, I think, is across this whole energy transition journey is there is no discounting how important partnerships are. And we have partnerships right across the board from transportation partners such as ExxonMobil, EPC partners such as Samsung E&A. And one of the things that we will be doing with our partners will be June 20th at the Samsung Enable Conference in South Korea that they are sponsoring for some of their key customers. And I really look forward to talking more about our Samsung carbon capture powered by ASCC Honeywell technology together with Samsung.
Well, thank you again, May, and thank you to our listeners. If you or your company is interested in recording a podcast, please reach out. For more podcasts like this one, visit carboncapturemagazine.com and subscribe for industry news. We hope that you enjoyed this podcast and look forward to next time. Until then.